So, hey everyone. I'm Pascal Brun, co-founder of Acurast, and here to talk about universal interoperability. You might have heard the term interoperability. I mean, before the speaker has talked about this, but over the past few days, quite a lot. So bear with me. Let's explore what the universal aspect of it is, because it's usually the common understanding that we nowadays have, that under interoperability we kind of understand cross-chain communication. So two chains essentially interacting with each other and exchanging messages, making a way how these systems essentially can work. With the universal part to interoperability, we look a bit more holistically at the whole space, so not only specifically on cross-chain communication, but we include a bit more other aspects of it. And we are essentially doing this because what we have been kind of observing in the space as of late or since its emergence is that there are a few things. If you look at decentralized applications, they're essentially relying mostly on real-world data. So if you look at a DeFi platform, they rely on price feeds coming from centralized exchanges, for example. And besides that, if you look at a cross-chain communication environment outside of ecosystems like Polkadot, where the chains themselves are connected, it's very hard to kind of have a native way of communicating essentially with all of these other ecosystems that are out there. And probably third on that list is as well, if you look at emerging technologies such as AI, having a way to bring them into the Web3 space is not really inherently there at all. So we have all of these worlds essentially around there, you can call them, that are also populated by developers that are highly funded, but in the end they don't have a native way of interacting with each other. And we think that this creates a huge opportunity, so essentially a way that this can be approached and solved, and this is essentially where Acurast comes into play. With Acurast, we want to be the way of how these interactions become as seamless as possible without essentially sacrificing on security and having to trust on centralized parties. So Acurast will be then the facilitator essentially that really interconnects these various worlds, so to say, together. So you include the legacy Web2 world into the mix. You can bring it into the Web3 space, but you can leverage the same underlying layer essentially for cross-chain communication, as well as getting exposure to these technologies like AI or IoT. Now you might think this sounds all a bit kind of hypothetical and very hard to essentially master, but what we're doing with Acurast is we're looking at a layered approach. So the Acurast protocol itself is the orchestration layer that sits essentially on the consensus side of the protocol. But the interesting part is that the execution layer sits off-chain. So there's like a trustless off-chain execution layer who does a lot of the computationally intensive tasks that then can be instructed by the protocol itself and is ultimately settled on the various networks, thus enabling this universal interoperability. Let's double-click more on the execution layer side of things, because I think that's a very interesting aspect of the whole project and the space at large. We have seen a lot of projects trying to solve this in different ways. So having these off-chain computational capabilities, we know that mobile devices are essentially very well suited to be utilized for this specific use case, because mobile devices on one hand they're very accessible, so you can essentially get them in any country, which means you can build up a way of a decentralized network. Maybe taking a quick look into the security assumptions around mobile devices and why they're essentially made for this. If you think about a mobile device, this is something that you, like every one of us, carries in their pocket. We use it for e-banking, we use it for crypto wallets, for all of these things. Even though if the device is getting stolen, we are not directly alarmed that all of our funds are being drained. And what we do with Acurast is essentially leveraging the same aspect of these mobile devices. So this specific hardware security module, a chip that sits on the device and allows us to essentially enable this trustless approach at computation. So let's quickly look at how this essentially works from a potential user perspective, because what we want to do and what you can already do on the Acurast side of things is that any individual or enterprise can essentially be onboarded to become what we call a processor. So the processors are these off-chain workers based on these mobile devices. And what we see here in this video is that we are onboarding a new device, a new processor, so to say. So we have connected to this Acurast console with our Polkadot account, and we are scanning this QR code with a mobile device that we're just taking out of the box. We're connecting it to Wi-Fi, and then the whole setup process is running in the background. So it's going to download an application, the Acurast processor application, setting up the device itself, and then joining the network, advertising the resources that this device essentially has within 5 minutes. So this is a very quick onboarding process that is very accessible to anyone to essentially participate and start offering these resources that are out there. And the interesting part that you also might have spotted in the end is that this device is dedicated and only for this use case. So it's not, you cannot do anything else with this device but offer the resources. And this is not something that you're doing for free. So you're being rewarded for providing these computation resources by the ones that are essentially consuming them. And we already have people in our community that might have taken this to a certain kind of access, but getting, for example, second-hand devices, kind of completing them again if they might have been broken, and then starting to set up a rack of these off-chain workers, fully participating in these networks and offering the computational resources that they have with this. Now, this is more the supply part of the execution layer, right? So we offer these, these individuals offer these computational resources. Let's take a look at in which areas or what they can be used for in the end. And we are taking a modular approach in that regard, so that we say there are specific modules for specific use cases. So if you look at the Web 2 space, where you have the example that I've made before with these price feeds, so public or permissioned APIs, then this is one of the modules that are essentially directly made for this. There are additional modules that enable this interoperability, like the cross-chain or cross-ecosystem message passing that also goes outside the Polkadot ecosystem, for example. And then other modules include AI and as well as IoT. And one of the important part on kind of the demand side, and in my opinion, a very, very interesting aspect of it is that the developer, or how it's called in the Acurast world, the consumer of these resources, they can specify their requirements in code. So this means in JavaScript, they're essentially specifying what they want to have to be run on these off-chain workers, on these processors. So this can be calling an API, doing computation on these devices, leveraging this cross-chain mechanism. It's completely in the hands of the developer to build for their specific use case, define this, and then get access to essentially this execution layer, the capacity of the off-chain workers that are out there. And this is not something that you're building on top of the Acurast protocol, as in terms of you're not utilizing smart contracts that are living on the Acurast protocol, but you're essentially developing in the ecosystem that suits your project, if you are looking at this from a developer perspective, the most. So what this means is that if you are building a parachain, you can leverage essentially the Acurast substrate palette that then receives all of the answers of these executions that these off-chain workers have made. So you need to think about it like the consumer has defined their requirements in code. This is being executed by a number of processors that you have selected, and then it's being brought directly onto this palette, for example. But it doesn't stop there. You can also use an EVM smart contract. So if your chain is within an EVM or has an EVM environment, you can utilize that as kind of the destination side of things. This also goes further with WASM. So also WASM environments are supported, as well as specific layer ones that you essentially can provide this data to. This is Bitcoin, Tezos, and others. So this is a very broad kind of area that you can essentially interact with the Acurast protocol and profit from the capabilities that Acurast itself, with this off-chain execution layer, offers. Now, let's think about quickly about these two sides, right? So we have the supply that is coming from these processors, so these off-chain workers that are set up with these mobile devices. They're offering their computational resources. And on the other side, you have projects or developers that say, I want to make use of these resources, and I have this specific use case that I'm building for, and I've defined it in code. How can I get access? And the answer is through the Acurast marketplace. So this is a completely self-service marketplace that is part of the Acurast protocol, where both parties essentially register themselves. So the processors that you have seen before in this video is checking into the Acurast protocol, where they offer their resources. And here on the other side, we can have then the developer, the consumer, with their in-code specified needs, going onto this marketplace and creating a request. So saying, I have this piece of code. I want this to be executed from tomorrow until the end of the year. I have a given interval of 1 minute, for example, and I need 3, 5, 10 of these processors to run this. And I'm also attaching a reward to it, because the developer side is the one paying. For example, 1,000 USDT for this execution. This is a transaction that you're doing on the Acurast protocol, and then the protocol itself will match this request with the given side, so the supply side on the other side. They are then starting to execute this in whatever you have specified, and pushing the answers, the output, essentially, to the destination where you're building in. So you have a completely trustless way to get access to this execution layer. There's no centralized party in between. Not us as the developers of the Acurast protocols are the ones saying, no, you cannot run this script. We won't allow it, or we're not doing a matching or anything. So this is really trustless in a manner that, and the cool thing is you can already do this today. Now let's talk quickly about use cases. So the most common use case that probably everyone is familiar is going more down the Oracle side of things with the price feed example that I've made, where you need to bring data from like a centralized exchanges or decentralized exchanges essentially on-chain. And how can you do this? So one example is you're directly specifying as a developer, I want the price of Bitcoin USD from Kraken, I want it from Binance, I want it from any other given exchange, and I defining all these kind of things, intervals and everything, so I have a huge flexibility also when it comes to long tail assets in the end. Then there's another way to look at this, which is kind of the common good approach, where we're going to be collaborating with foundations or entities within specific ecosystems that, for example, have an EVM environment, which developer sit on and want to consume this. So this is then, you can understand about this, like a top 10 price feed, for example, that can easily be consumed through the Acurast protocol. And then something that is very exciting, and I think one of the more interesting things around this is before, for custom and these common good feeds, we think about intervals, so transactions that are being pushed on chain. Specifically, each of these transactions are being signed, and someone needs to access them. What we can enable with on-demand is a direct connection to these off-chain workers. So you have really kind of a sub-zero response time, and you can build way more in-time application, where, for example, in the use case here of price feeds, the movement of a price can be very hard or very fluctuating within an interval of a minute. So what we want to do is, when I'm creating a request, I directly want that the price is being fetched and being included. And this is offering kind of, or enabling completely new use cases for DeFi protocols or DeFi products, for example. Now let's explore a bit more outside of the common understanding on price feeds and the Oracle use case. Things that Acurast can enable. This is not an exhaustive list, but cross-chain communication, so being able to pass messages from one ecosystem to the other through this execution layer. So you can build decentralized applications that live on one ecosystem that is also can also be outside of the Polkadot ecosystem, and then is being enabled or triggered by interacting with an EVM chain or whatever you have it. In terms of Web3 multiplayer games, this is very interesting. So you can use this on-demand approach, for example, and offloading all of the heavy computation outside to to the execution layer itself, where you can do all the processing and decision making on the games, relying on this trusted execution environment, and then pushing essentially the answer or the output of this on-chain again. So you have a very scalable way to break into the gaming space and build completely new Web3 enabled games. With confidential AI inference learning, this is something very interesting for us to explore as well. If you think about current AI learning, you're relying on like very centralized companies like Google or Microsoft, where you provide all the data, the whole data set to them, as well as they essentially have access to the output of that. Here you can leverage all of these off-chain workers that are completely decentralized, set up, do the learning on these devices, and get the answer back without essentially exposing the data to any centralized party. Then last but not least, something very interesting as well is enabling for the Bitcoin network essentially to build smart contracts. So leveraging again the execution layer to do a certain computational, certain transactions, building a specific kind of a set of instructions into this, and then bringing it back to the Bitcoin protocol. So as I've said, this is a non-exhaustive list, just a way of use cases outside of essentially the basic Oracle use case. So what can you do now? You can already start playing around with it on console.acurast.com. You can get a phone. There's a list of devices that are supported. You can get it onboarded and provide the resources to the Acurast protocol. If you're a dev project, you can also go to the console.acurast.com, create one of these requests, play around, and get the outputs to the chain you're building on. More docs or more details are in the docs, docs.acurast.com, and at Acurast on Twitter, Telegram is where you can get answers if you have any questions. Awesome. So we're also at the time limit, so I'm unfortunately not able to take questions, but I will be around the conference. Happy to chat as well. Thank you.